In this episode of SolidWorks for Creo Parametric users, we will take a look at a mate that does not have a direct analog in Creo Parametric. Just as a reminder, a mate is the same thing as a constraint in an assembly in Creo Parametric. So in my SolidWorks session, I have three parts open that I want to make an assembly for. First, I have this mill base part. And then I have a saddle that goes on top of the base. And then I've got a working table that goes on top of the saddle. Let me go back to the first window that I have open, and I need to create an assembly. One of the options that you have in SolidWorks is to go to the File drop-down menu and choose Make Assembly from Part. And so that opens up my assembly window. Then I get the Begin Assembly dialog, and I have a list of the different parts that I have open in my session. The first one is the mill base, and that's one that I want to start out with. You can actually select multiple parts, but I'm just going to bring in this one, and there's an option to only fix the first component. You could change that to fix everything or leave everything floating. I could move around and place it somewhere in the window, but I'm just going to hit the check mark in order to locate the component and fix it. If you take a look in my design tree, you can see the first component, and it's got that F in parentheses indicating that it is fixed. So that is good for the first component. Let me bring in another component, and when I go to the insert component command, it opens up essentially the same dialog, and I could insert multiple components at the same time if I want to, but I'm just going to do them one at a time to show you the different mates that I'm going to use for these. And I'm going to move it somewhere in the main window so that is not sitting on top of the part that is already there. So I'll just left click in order to drop it. You can see that is listed in here, and the little minus sign inside of parentheses indicating that it is not fully constrained. It still has degrees of freedom. In order to eliminate those degrees of freedom, I can add some different mates in here. And so again, this is one of the differences between Creo Parametric and SolidWorks. In Creo Parametric, when you bring in a component, you add the mates, or rather the constraints in Creo Parametric, in order to eliminate the degrees of freedom. In SolidWorks, you can throw in all your components and then add mates, and you can add mates in sort of like any different order. It doesn't have to be dependent on like parent-child relationships and stuff like that. But anyhow, I've got this first component located in the model. Let's bring in some different mates. So I will click on the mate command. The first thing that I want is a regular coincident constraint. I don't have to choose coincident, just like in Creo Parametric. If I just start picking geometry, it'll select the different entity. So I'll grab that one and let me rotate and pick this surface. Now it has made those two surfaces coincident. You could change the alignment or change to, parallel or perpendicular, or use one of the other different options, but I'm happy with this one. I can right mouse click in order to get to the OK check mark, and I still have the mate dialog open so that I can start adding more mates into my assembly. Let's take a look at the one for this video, and it's called the width mate. And I get to it by going to the Advanced tab, and so we have some different mate types like Profile Center and Symmetric and Path Mate and Linear Coupler, but I'm going to choose the Width Mate. And with the Width Mate, you are going to select two planar surfaces from one part and two planar surfaces from another part, and then it will center the middles of those different references that you pick. And so this is one of the things that people who use SolidWorks really like about SolidWorks, because it saves the trouble of creating datum planes or putting datum planes in the middle in order to add constraints like coincident between those different datum planes. So for the first example, I have some angled surfaces in the different parts. And so let's select this angled surface and then this angled surface. And these are two surfaces from the same part. So those two width selections are defining essentially a midplane in between them. And then I'll go right to selecting the next two width references. By the way, I want to mention that I'm not holding down the control key. That's one of the differences between Creo Parametric and SolidWorks. Creo Parametric, you would select or you would hold down the control key for selecting multiple entities or multiple entities from the same component. But in SolidWorks, it sort of has persistent selection. And so now it's taken those different references and it has centered them. Let me zoom in a little bit. You can see that we have a gap between the pairs of different selections. So again, that is the width mate. Let me hold down the right mouse button and hit the check mark in order to create that mate. And it leaves the mate dialog open so I can create other additional ones. Let's do another width mate. I want the saddle part centered on this angled part of the base. So let's once again go to a width mate and I will let's pick from the base part first. I'll select that surface and this surface. And then for the other pair of surfaces, I'll pick this one and this one, and it readjusts the location. And by the way, it readjusted the location because there is an option turned on to show the preview. One other thing to mention about the the width mate is that there is a set of choices. By default, it is set to centered. You could change it to free, where you're not specifying that it's centered, or you could use a dimension, or you could use a percentage to locate the components relative to one another. So that's good for this. Let's hit the check mark in order to close out. And I'm actually going to cancel out of there because I want to show the same commands over again in the third component. Let's go to Insert Components. Let's grab the one I have not inserted yet. And right now I could drop it in here, but I actually want it rotated. And let's see, if I take a look at the little triad in the lower left-hand corner, I'm gonna rotate about Y as I'm placing this. That's good. That's sort of like how I want it in here. And so I will left click in order to drop it. And now I can start adding some mates for locating this component. Oh yeah, speaking of which, actually, let me cancel out of here for a moment. If we take a look at the saddle mill, it no longer has that minus sign in parentheses because it is fully constrained. There are no more degrees of freedom, but the working table has the minus sign because there are no mates regarding it. So let's go to our mate command. Once again, I will start off with a simple coincident mate. I'm not going to choose the mate that I want, but let's just pick this flat surface and rotate and grab that. Oops, I think I got an edge there. Let me clear that and let's see, let's go with, let's see, what do I want? I want this surface. It's going to be a little more careful about how I'm picking. Oops. My zooming is all over the place because, again, I'm just not as used to how you do things in here. But anyhow, I've got that in there. That's good. Let's hit the check mark for the first mate. And now I will select the Advanced tab. Let's do our width mate. And I will pick this flat surface. And let me rotate and pick that flat surface. And let's grab this planar surface and this planar surface. And there, once again, we have the surfaces centered on one another. Let's put in our other width mate. I will hit the check mark. Let's choose width. I like to pick width explicitly. I can pick this flat surface and this flat surface. And let's pick this surface and rotate and grab this surface. And once again, they are centered. Let me hit the check mark and I can cancel out of creating my different mates. So there you see it. There's how you can use the width mate in order to center components relative to one another when you are in an assembly.